In this video, I set you an exercise where I ask you to find the representation of a positive and negative value using a sign magnitude binary nibble. It's a follow-on from the last video in the playlist. I'd like you to have a go at the exercise represented by A and B. A is asking you to represent +5 by a sign magnitude binary nibble, and B is asking you to represent -5 by a signed magnitude binary nibble. Pause the video and have a go. When you've had a go, restart the video where I will show you the solution to both. I'm starting off by showing 5 equals this in binary, and the 10 and the 2, they're there simply to remind me that I'm dealing with denary and binary. They're not part of the number. What we can do, we can take the binary pattern and I'm going to place them in flip-flops, as you can see here. Now this is not a nibble. For it to be a nibble, I need to have space for another bit in the most significant position, because I do not want to alter the value, because what I'm going to put in here is 0. So this nibble still represents 5, because remember, when you're talking about binary, they're going to have these place values. If we have a look at what these place values give us, they give us the following. This 0 means we have no lots of 8, which I'm showing here. This 1 means we have one lot of 4, which I'm showing here. This 0 is because we have no lots of 2, and this 1 is because we have one lot of 1, and if I now consider these and add them up, we get 5. Consequently, this nibble here is going to represent 5, and I'll show it moving into the appropriate position on this slide. So we can see that 5 as a nibble is this value here. This is the unsigned representation of 5 in a binary nibble format. The question asks you to show it as a signed magnitude representation, which is what I'm going to go on to in the next slide. So we can see here it is saying represent +5 by a signed magnitude binary nibble. Let's have a look at this. We know this is an unsigned representation of 5 as covered in the last slides in this video. However, what we can do, we can consider this now as a signed magnitude representation, and that is achieved by us realizing that the one I've shaded in yellow is going to represent the sign of the number, and because it's 0, this means the sign bit is going to be positive. So you can see I'm illustrating that as being positive. The other 3 bits, well, that's the magnitude. And we know that this will give us 5, because this is worth 1, this is worth 4, and when you add them up, you get 5. Consequently, the nibble you're looking at here is actually representing +5. This is the sign bit representing the positive, and this is the magnitude representing the 5. Now part B is asking us to represent -5 by a sign magnitude binary nibble. Now my starting point for this is going to be how we represented +5, which we did on the previous slide. Now to obtain the negative value of 5, the negative representation, it's pretty straightforward. What you do is as seen here. The 5, which is the magnitude, is placed here, and the sign here, which was 0, is put here as a 1, meaning negative. So this binary pattern equals -5, where this is the sign bit representing the negative, and this is the magnitude representing the 5. So what you can see in front of you is this is how you represent +5, and this is how you represent -5 in signed magnitude binary nibbles. Let's consider the nibble. The area that I've just shaded yellow, well, that is the sign bit, and because it's a 1, it represents negative. The remaining 3 bits, well, that's the magnitude, and that has the magnitude of 5. Consequently, the nibble equals -5. This is the sign bit that gives us the negative, and this is the magnitude that gives us the 5. So you can see that this nibble represents -5. Now, there are some issues associated with signed magnitude binary representation of numbers within a computer, and I covered it in the previous video, but I'm just going to mention them here because I would like to encourage you to look at the previous video so you can have a look at what the issues are associated with signed magnitude binary values. So if we consider what we have, the last video showed us that a signed magnitude binary nibble had the disadvantage of having two binary patterns representing 0, and that's something that I've covered in the previous video. The other thing we need to concern ourselves with is the range you can have with a signed magnitude binary nibble is from -7 to +7, which means it has 15 combinations available to represent the numbers that are both negative and positive in the range that I've just mentioned. Now, that's because there are two patterns for 0. And you really don't need two patterns to represent a number. You need one unique one. So as I say, I've covered that in the previous video. For completeness, let me remind you that an unsigned nibble can represent 16 combinations, from 0 through to 15, which is 16 possible numbers. But of course, it cannot represent negative numbers, but it can represent one more number than can signed binary nibbles. And again, all this has been covered in the previous video in the playlist, which I recommend that you remind yourself of. Please consider subscribing to the channel and click the bell to ensure you get an update every time I upload a video. Maybe you would like to consider supporting the development of these free videos via Patreon. In addition, why not follow me on Twitter and also check out the supporting website.